The domain of a function. Again, the domain is related to things that are not mathematically allowed. For example, you can't divide by 0, so in this function, can't divide by 0, so the denominator cannot be 0. So you look at what would make the denominator equal 0. So what would make the denominator equal 0? Set it equal to 0 and solve. X equals 4. So that means everything is okay except x cannot equal 4. So you could write that as all real numbers except 4. You could also do it as an interval from negative infinity to 4, not including 4. Union, picking up right at 4, but not including 4, to positive infinity. A couple more examples. Another fraction one, the denominator can't be 0, so set it equal to 0 and solve. You'll find what it cannot equal. So in this case, we'll factor x minus 1. Tee it up, we get x equals 0 and x minus 1 equals 0, so x equals 1. So x cannot equal 0 or 1. So as an interval, this domain would be negative infinity, 0 would come first, so negative infinity to 0. Union, then from there we can go from 0 to 1. Union, and then it picks up at 1 and goes to infinity. 1 to infinity. I like to think of removing things from the domain, like thinking of the number line as a string. You have a string that you cut at these two places. So if you make 2 cuts in the string, you're going to get 3 parts. To the left of the first cut, between the cuts, and after the second cut. For our next example, g of x equals a square root. Now with square roots, you cannot take the square root of a negative number. You would get an imaginary number. So the inside, the radicand, it can't be negative. So you could look at it needs to be greater than or equal to 0. You could write it as an inequality. And you go ahead and solve this. Negative x squared is greater than or equal to negative 9. Divide by negative 1 to change the signs, but we need to flip the inequality, so x squared has to be less than or equal to 9. Square root both sides. When we take the square root, it's going to be plus or minus 9. So let's just say x equals plus or minus 3. And then to make sure where exactly it is, you could take test points. I know that it's going to be has to be between negative 3 and positive 3. You can also figure that out kind of by looking at this. If you subtract anything more, it would become negative because you'd be subtracting more than 9. So it has to be between negative 3 and positive 3. Negative 3 to positive 3. And you can take the square root of 0, so that means that the endpoints are okay because it was or equal to. So the endpoints are okay, so you put square brackets. For our final example here, we have a square root in the denominator. So we know that we can't take square roots of, we can't take a square root of a negative. So t plus 1 has to be greater than or equal to 0. But if we take the square root of 0, we get 0, and we're not allowed to divide by 0. So it can only be greater than 0, not equal to. So t has to be greater than -1. So as an interval then, t has to be greater than -1, so that would be from -1 to infinity. And the -1 is not included, so another parenthesis. So remember, the trick to finding domain is just knowing what you are not allowed to do mathematically in the function. You can't divide by 0. You can't take a square root of a negative. There are 4 ways to represent a function. Let's start by looking at the algebraic representation. That would just be writing out the function using numbers and variables. So in this case, we have a of r equals pi r squared. You should recognize that that's area of a circle. So the verbal representation for the same function would be the area of a circle with radius r is pi times radius squared, pi times r squared. The area of a circle with radius r equals pi times radius squared. A visual representation would just be like the graph, which for this same function would just be like a parabola. And that's a visual representation of the function. And for numerical, that means like a table. So if you're given the radius, then what would the area be? So if the radius were 1, area would be just pi. If the radius is 2, area is 4 pi. If the radius is 3, area is 9 pi. So there's 4 different representations: algebraic, verbal, which, again for this one, area of a circle with radius r equals pi times r squared. Visual, which would be like a graph, and numerical would be like a table.